Welcome to CuriousClicks. Today, we explore Shaduf counterweight water lifting and the evidence behind its most surprising mystery. How can a simple pole and weight make repeated buckets of water easier to lift? That is the puzzle this documentary will solve. Before the history, we need to understand the physical problem, then follow the mechanism and the evidence until the answer becomes visible. Start with the scale of the problem. Grissmer, 1999. Performance characteristics of the Shaduf, a manual water lifting device. That sets the scale of the problem the rest of the explanation has to solve. Start with the scale of the problem. The Shaduf is a traditional device to assist human beings in lifting water 1 to 6 m, 320 ft, by minimizing and distributing, over time and among various muscle systems, the forces that need be applied by the operator. That sets the scale of the problem the rest of the explanation has to solve. Start with the scale of the problem. A study of efficiency in various sites in Chad has shown that one man can lift 39 to 130 liters per minute over heights of 1.8 to 6.2 m, resulting in water lifting power levels of 26.7 to 60.1 W. That sets the scale of the problem the rest of the explanation has to solve. Start with the scale of the problem. System outputs, with lifts ranging from 1.8 to 6.2 m, 5.923 ft, were 0.65 to 2.18 ls, 10.33446 US gallons min, resulting in water lifting power levels of 26.7 to 60.1 W, 0.0360081 HP. That sets the scale of the problem the rest of the explanation has to solve. Start with the scale of the problem. The bucket can be lowered by the operator using their own weight to push it down. The counterweight then raises the full bucket without effort. 4/8. The implementations vary from region to region. That sets the scale of the problem the rest of the explanation has to solve. Start with the scale of the problem. The Shaduf project, a European Commission report on Mediterranean Shaduf use and history categories. 3rd millennium BC introductions ancient Egyptian technology irrigation sargon of Akkad tools water wells. This page was last edited on 8 June 2026 at 18:55 UTC. That sets the scale of the problem the rest of the explanation has to solve. Start with the scale of the problem. Therefore, the origin of irrigation is inseparable from that of agriculture. Drower, water supply, 520. The technology of irrigation was developed at this time to move water to the fields from nearby rivers. That sets the scale of the problem the rest of the explanation has to solve. Start with the scale of the problem. As Chant points out, Greek systems of water supply and management could be quite complex, involving aqueducts, closed pipe systems, settling tanks, cisterns, and fountain houses. Chant, Greece, 72. The constant, consistent supply of water to Greece had many cultural implications. That sets the scale of the problem the rest of the explanation has to solve. Start with the scale of the problem. The gardens, fields, and orchards of their narrow but very fertile coastal plain had a perpetual supply from the mountain streams of Lebanon. Ibid, 531. The transportation of water was extremely important because it sparked cultural changes. That sets the scale of the problem the rest of the explanation has to solve. The surviving evidence gives us a firmer clue. The short end carries a weight made of clay, stone, or a similar material, which serves as the counterpoise of a lever. Its value is that this is evidence we can inspect, not a detail added merely for atmosphere. Now follow the mechanism one step at a time. However, the Egyptians eventually began to develop irrigation technologies. In early times, the irrigation was done with pots dipped in the river by means of a criss-cross of channels into which the water was poured. Drower, water supply, 542. The invention of the Shaduf, a wooden device for lifting water, was used to aid this irrigation and to water the Egyptian gardens. This is one link in the cause and effect chain. The next step has to connect to it physically. Now follow the mechanism one step at a time. The creation of aqueducts to transport large amounts of water over considerable distances also developed. Remains of aqueducts near the Syrian coast show how the Phoenicians led water long distances over uneven ground by channels and embankments. This is one link in the cause-and-effect chain. The next step has to connect to it physically. This is also where the evidence has limits. Eventually, irrigation schemes enabled perennial irrigation to be practiced on a far larger scale, and presumably turned the depression into a market garden where cereal crops, as well as fruit and vegetables, may have been grown. Ibid. 545. The development of this new irrigation system also helped control the flooding of the Nile by carrying away, and then returning surplus water to the Nile. That limit matters as much as the conclusion. A mature reconstruction should not claim more than the evidence supports. Another piece of evidence changes the picture. Performance characteristics of the Shaduf, a manual water-lifting device published by the American Society of Agricultural and Biological Engineers, placed beside the earlier evidence. It narrows the explanation and removes another possible guess. Return to the original question. How can a simple pole and weight make repeated buckets of water easier to lift? The answer is not one magical component. The evidence shows how the relevant parts of Shaduf counterweight water lifting work together under real constraints. How a counterweighted lever let one person raise irrigation water with less effort. That is the useful engineering story. A chain of causes that can be inspected, tested, and explained. Thank you for watching. Please subscribe to CuriousClicks.